This is Module 10, Basic Router Configuration of the Cisco Network Academy Introduction to Network 7.0 course. First, we must do initial router settings. I normally refer to these as router housekeeping, such as a name. Now, you'll notice the prompt, we're in global configuration mode. When we first log on to a router that has not been configured, it would have the greater than sign indicating that we are in user mode. We must then type in enable or just plain EN to move us into privileged mode. Then we would type in config T or configure terminal to put us into global configuration. We can then program things that are globally significant, such as the host name. Any command we can abbreviate as long as we have enough letters to make it unique, such as host name could be simply host and then the name. Normally, I prefer to put all my host names in capital letters. This makes it very easy to distinguish between what is a name versus what is a command. We then create an enable password. Now, in this case, it is a secret password, meaning that when we use the keyword secret, it encrypts it with MD5 encryption. If I were to say enable password and then the password, there would be no encryption unless I turned on global encryption for the device. I then configure my lines, my console line, my VTYs. If it has an auxiliary, I would configure that. So I would go to line console. Notice how the prompt has now changed to line. It is the same prompt when configuring virtual terminal, VTYs. So you do not know from the prompt which line you are configuring unless you keep track of where you are. We enter a password on the console, and we tell it to use it with the login command. Many people forget to put the login command, so they are not able to get in via the console. The VTYs are for remote access, virtual terminal. We're telling it to use the password, and then we can say transport the input. We can use SSH or Telnet or both. In a production network, SSH, which encrypts the entire frame, is the preferred method. If I turn on service password encryption, any passwords that I either don't or can't encrypt with the secret command will be encrypted with MD7. I also want to leave a banner message of the day. The message of the day starts with a character and ends with the same character. The only thing is that the message cannot contain that character. You must use a different character from the keyboard. Once we are done, we end, and After verifying that our configuration is correct, we would copy the running config to the startup config. The message that we put in the banner is normally a legal message that this is a production, it is not to be tampered with, it is not open access. You never put a message that welcomes anyone into your router. Here is a basic example that we give a host name, our secret password. We configure our console line, our VTY line. We may also be configuring an auxiliary line. Here, they're telling it to use both SSH or Telnet, although SSH is the preferred method. The banner can be multiple lines, as we see here. We exit, which will bring us back one level. Notice how exit here only brought us back one level to config. Exit at config brings us back to the normal prompt. And we save our running config to the startup config, which is saved in NVRAM, non-volatile RAM, so that if power is lost, the configuration will still be there. To configure an interface, first, we must know the interface. So a very handy command would be to show sh IP interfaces brief. This will show you the names and numbers of the interfaces that are on your particular device. There are multiple different types of devices, and no one person can be expected to remember all the interfaces on all the different models available. So using the show IP interface brief command is very handy to find what interfaces your particular device has. Once you have done that, you can say interface and the type and number of the interface that you wish to configure. Notice how the prompt changed to config IF for interface. It doesn't matter which interface you are configuring, the prompt will always be the same. It is good practice to put in a description, because although you may know where a particular interface is connecting, another user may not. We would then give it the IPv4 address along with a subnet mask. An interface can only have one IPv4 address. Therefore, if you enter the wrong address, you can simply re-enter it with the same command of IP address, the corrected IPv4 address, and subnet mask, and it will replace the first. In IPv6, we do not have a subnet mask. We have a prefix length. So we would use the command IPv6 address, the address, and prefix length. An interface can have multiple IPv6 addresses. Therefore, if you mistype or enter the wrong address, you need to put no in front of the same command that you used to create the IP address to remove it. Once the interface has been configured with the addresses and any other commands that it may need, you can say no shutdown. This turns it on. If for some reason you need to troubleshoot a network and you do not want this interface up, you could also say shut. As we said earlier, it is always a good practice to have a description. And the no shutdown turns it on. If you do a show IP interface brief and it says administratively down, it means that you did not do the no shutdown command. Here is an example which I configure after the end of these slides in Packet Tracer, the entire circuit. Notice here we are just configuring gigabit 000 of R1. We give it a description linked to LAN, although you may want to be more descriptive, such as link to the PC1 LAN or link to the engineering or sales LAN. We give it the IPv4 and then the IPv6 address. You may also wish to put on a link local IPv6 address. As soon as we put on an IPv6 address onto an interface, it will automatically generate an IPv6 link local. But you can also add on your own link local address, such as IPv6 address FE80. Link local addresses begin with FE80, colon, 1 for router 1. And then we say link local. Communications in IPv6 take place over the link local addresses. Just because we used FE80 for gigabit 000, that does not preclude us from using the same link local address for gigabit 001. Every interface on router 1 could have the same link local address because it is unique and only used on that link. So it can be used multiple times because its significance is only to a particular link connection, not a global significance. Here we are configuring gigabit 001 of the same router, a description of who it connects to, the IPv4 address 209.165.200.225. Notice how here we give the network, while here is the very last octets number. We put in the IPv6 address. And as I said earlier, the link local could be exactly the same. As we configure interfaces, we will see them come up or sometimes come up and go down, such as configuring gigabit 001 of R1. It may not come up until the interface of R2 is configured and also brought up. Here is the command of show IP interface brief. As I said earlier, this is a very handy command. Also, show IPv6 interface brief is very handy because it will show you the IP addresses as well. We can see here that the link is up and up. The status is the electrical qualities, while the protocol is the logical qualities. On a link, you can have up and up, which is what you are looking for. You can have up and down. And this might be where one end of the link is configured for a particular encapsulation, while the other end is configured for something else. You could have down and down. As in this case, no shut command was put in, so you could have administratively down. The only one that you cannot have is you cannot be down electrically and up by the protocol. There is no way in the known universe that this can happen. As you can see here, as we put IP addresses, IPv6 addresses, on the interface, it automatically generated its own link local. This is done automatically whether you put a link local address on the interface or not. These are some of the commands that we would use. Show IP interface brief or show IPv6 interface brief. And it shows all your interfaces and their current status, whether it's up and up and down and down, administratively down. Once we have a routing protocol in, we would say show IP route or show IPv6 route. We can show our interfaces to check to see if there have been resets or what is the status of an interface. Show IP interfaces. This will display the IPv4 statistics. And show IPv6 interfaces. This will display the IPv6 statistics. These different commands are tools. Just like a carpenter may have many different types of saws, we have many different types of commands. Will we use them all on the same job? Probably not. But knowing that they are available to us and with the type of information that we can get from them is very important. Here is the show IPv or show IP interface brief and the show IPv6 interface brief. You'll notice it also gives us the address as well as telling us whether we are up and up or down, administratively down, and IPv6. It also gives us the link local as well as the global unicast. And it shows us whether we are up and up, or in this case, administratively down. The show IP route command is extremely handy. They've omitted some output which gives you a description of what all the labels mean. The index. We can see here the C's and the L's. These are directly connected networks. We can see the 192.168.10.0 with the /24. The L is the local address, 192.168.10.1, and a subnet mask of 32. That is the address. If I say show IPv6 routes, I get the same information. Remember, if you do not have a route in your routing table or a default gateway, you cannot get out of the network that you are in. If I show my interface, it will show me whether it is up. It will show me the hardware. It also shows me the MAC address of that interface. IPv6 uses the MAC address to help establish an IPv6 address, as we will discuss in a later chapter. It shows me the description, the actual address, the MTU size, bandwidth. It also shows me things like the last input, a queuing strategy, and what does the queue look like. Also, have I gotten any runs, giants, or throttles? Do I have any resets on the interface? So it gives me a tremendous amount of information to help me troubleshoot what could be a problem. The show IP interface versus show interface gives me different types of information, such as the address, broadcast, the MTU size, help address, directed broadcast. Do I have any access lists, either outbound or inbound? So it gives me other types of information that I may need to troubleshoot the network. Here, if I show my IPv6 interface, it will give me my IPv6 address. It will give me my global unicast address. It will tell me which groups I have automatically joined. We use these to connect from router to router or to hosts. It will tell me about my ICMP error messages. And it will tell me about what network discovery I'm using, such as DAD, duplicate address discovery. DAD will replace what we normally see in that we have two addresses the same on a network. To configure a default gateway, we have to tell the router where to go if we don't know, or in this case, on a host. The default gateway brings us to another network. The only way PC1 can get to another network is by going through the router. So its default gateway will be 192.168.10.1, the way out, while PC3 and 4 would need to go to 192.168.11.1 to get out. A switch also has to have a default gateway. In the packet tracer recordings that follow the slides, Because Packet Tracer does not include an IPv6 default gateway, some of the network was unreachable. So a switch must have a default gateway address configured to remotely manage the switch from another network. This is where we want to use SSH. And to configure the IPv4 default gateway on a switch, we use the command IP default gateway and simply the IP address. There is no subnet mask. It is just the address of the default gateway. This, although short, is an important chapter. Make sure that you watch the video that I have included after the slides. It goes through and configures the entire network using Packet Tracer as well as Notepad to make the configurations. Today, we will discuss the initial configuration of a router or a switch. Routers and switches, as far as the initial configuration, are very similar. In Packet Tracer, I have brought up a generic router. This router has no configuration, and as you can see, it is now asking us if we would like to enter the initial configuration dialog. The normal answer that we will use is no. If for some reason we were to enter yes, we can always escape from the initial configuration dialog by pressing Control C. So for today, I will say no. As you can notice, we are in a router, and we have router with the greater than sign as the name. The greater than sign indicates that we are in user mode. Our options here are very limited. So first, we want to go to privilege mode. The command to do that is enable. You can see how the prompt changed to the pound sign. Here we can start making changes, but the changes are limited. First, I want to start making changes to be global. Global changes would be things such as the host name, globally significant to the router. In order to get into global configuration, we will enter the command config or configure terminal. If I misspelled something or entered the wrong command without the proper syntax, it would show me with a caret underneath the command. The command would not be part of the configuration. I would therefore have to go back and correct the command. Always watch what the display is telling you to see if something has been entered incorrectly and therefore not part of your configuration. Here you'll notice that the prompt now says router with configure after it. This is global configuration mode. The first thing that we will shut off is a DNS lookup. In certain situations, DNS lookup is handy. In our configuration here, if I were to type in something misspelled, the router may lock us out for up to 5 minutes while it looks to try to resolve the misspelled name through a DNS server that is not available. In order to shut off the DNS lookup, we will say no, IP domain dash lookup. I also want to name my router at this point. So we'll say host name R1. And I normally use capital letters to indicate a proper name. It makes it much easier looking over a configuration if your proper names are in capital letters. I want now to enter the domain name. And we will make this IP domain dash name Cisco dash CCNA.com. Once I have put in the host name and a domain name, I can create an encryption key. The encryption key will be used to access this router remotely. The way that we create an encryption key is we say crypto key generate RSA general key, and you'll notice that I only need to type in part of the command. Hitting the tab key will complete the instruction. Modulus. And as we can see here, using the question mark, it tells me I must enter a number between 360 and 4096. The larger the number, the more secure the encryption key is, but the more processing power it takes. We will use today a modulus of 1024, and it gives us a message. And the message tells us that it's a level 5 message, essentially a notification, and that SSH 1.99 has been enabled. When we configure our virtual terminal lines, we will use SSH. I now want to also make sure that our passwords are secure. As a default, I could use one character as my password. This is not very secure. So we will say security, passwords, minimum length, and we can set our minimum length. Today, I will set our minimum length to be 10. Because I will be using IPv6, I also want to turn IPv6 on. And to do that, we will say IPv6 unicast routing. I also need to give a message to someone trying to use this device. The way that we do a general message is we say banner, MOTD. It stands for message of the day. And it will begin with any character and end with the same character, but the character cannot be part of the message. Today, I will start with the ampersand. And I will say administrator, access only. And I will end with the same character, the ampersand. I now need to start configuring a password. We will say enable password, and I need to create a password for this, and it will be Cisco EN PASS. It is over the 10 characters. Remember, a space would also be seen as a character. Now, we have put in an enable password, but we need to check to see if this is secure. Now, I cannot do a show run from configuration mode straight. I need to tell it to look for that command in other menus. The way I do that is putting do in front of it. So I will say do show run. Now you can see, here's my enable password. Anyone looking over my shoulder could see that. So it is insecure. I want to make sure that any passwords that are not encrypted are. So I will use the command service password encryption. This tells it to encrypt any passwords that I have not encrypted through another method. If I show the same configuration, we'll see now my password is encrypted. The 7 indicates that it is using MD7 encryption. This is not a secure form of encryption, but it is better than having an open password. I'm now going to remove that particular password. And the way that we remove something is to put no in front of it. No enable password. A better form of encryption for this would be to use the keyword secret. So I will say enable secret Cisco EN PASS. If we were to again take a look at our running configuration, we'll now see a much better encrypted password. This is using MD5 versus MD7 encryption. I've now completed most of the generic, globally significant configurations. As you can see, I have service password encryption, a minimum length of 10, my host name, my secret password, unicast routing, no IP domain lookup, my IP domain, and a banner message. I can now configure some of the lines that will be used to gain access to this router. The first is the console line. So I will say line console 0. You only have one. Notice how my prompt changed to config -line. I am now going to give this a password. Cisco, con, pass. Now, just by putting a password on doesn't mean that it will use it. In order to make it use it, I have to say login. I will now also tell it that in case a message comes up, I do not want to be typing at the end of the message. So we will say logging synchronous. Now, in case I'm logged in and I walk away, I do not want this to stay logged in indefinitely. To stop that, we will say executive timeout, and we can put it in minutes and seconds. Here, I will say after 10 minutes of inactivity, log me out. I've now configured my console line. I now want to configure my auxiliary port. So we would say line auxiliary 0. There is only one auxiliary. Some equipment does not have it, and therefore you would not be able to configure it. We will say that the password here is Cisco AUX pass. Just like on the console port, we have to tell it to use it. Login. We also want logging synchronous. And we will set the executive timeout for the auxiliary port at 5 minutes. Now, the next set of lines is our virtual terminal lines. You'll notice here that even though we were in the console and the auxiliary, the prompt was the same as config-line. You need to make sure of what you are configuring as you work. I'm going to get out of this because before we configure our virtual terminal lines, we need to create a user. I'm going to create a user with the command username, and we will say it's admin user. Now, this did not have to be 10 characters because this is the name. The password will have to be 10 characters. Now, we're also able to put in the privilege level. Cisco equipment has 16 privilege levels, 0 through 15. 0 is user mode. 15 is the highest mode, where you can do any of the commands. Modes in between, there are some commands that would not be available. Here, because this is the administrator, I will say privilege level is 15. If you do not specify a privilege level, it will be 15 by default. We will then say what is the secret password, because I want this to be in MD5 encryption. If I just said password, the service password encryption command would make it an MD7. But we will say secret, and now this must be 10 characters. Administrative user, PA SS for their password. We can now configure our virtual terminal lines. So I will say line VTY 0 space 4. A router has 5 virtual terminal lines labeled 0 through 4. A switch has 16 labeled 0 through 15. Here, instead of giving it a password, we will tell it to use the username. The user is in a local database, so we will say login local. We also want to say login synchronous. We will set an executive timeout of 15 minutes. And we want to tell it to use encryption. And the way that we do that is we say transport input, and we're only going to use SSH. So it uses the encryption key along with the username and password that we have set. We can now start to configure our interfaces. If I am not sure of the interfaces, I can say do show IP interfaces brief. And you can see we have 3 gigabit interfaces, 00, 01, and 02. For this demonstration, I will use gigabit interface 00. So I will say interface gigabit 0/0. Notice how my prompt is changed to config-if. I can now put in first a description. It is always a good practice to have a description. And I am just going to call this a connection to a test network. It is always good to have the description so that users that may not be familiar with your company's network know where particular interfaces are going. I'm now going to set an IP address of 192.168.10.1 and a subnet mask of 255.255.255.0. Now, an interface can only have one IPv4 address. If I have found I have made a mistake, I can overwrite this address without performing the no command. Assuming that I had the 10, maybe it should have been the 11. So I can put in the same command, but just change the 10 to 11. Now if I say do show run, we'll see that only the 11 is on gigabit 00. Notice too how we can change from one mode, such as line, directly to interface without going back to global configuration. Now, earlier I had said that we will put on IPv6 addresses. And as such, we made sure that we turned on IPv6 unicast routing. I'm still in the interface, and the way that we enter an IPv6 address is IPv6 address. If I were just to say IP, it assumes it's an IPv4. So here we will say IPv6 address 2001 colon DB8 colon ACAD colon 1 /64. You'll notice here we do not put in a subnet mask on an IPv6. We put in the prefix number, /64. Now, unlike IPv4, an interface can have multiple IPv6 addresses. So if I were to make a mistake, I would have to go back and put the no form in front of the command to remove it. We're going to add a second IPv6 address here today, which is a link local address. Communications between routers and switches, as far as IPv6 is concerned, is done by link local addresses. So we will say IPv6 address. Link locals begin with FE80 colon 1. The same link local could be on every interface of this router because it is significant only to the link. This does not have a prefix link, but we must say that it is a link local address. If I were to do show run again, we would see both addresses are on the interface. The only thing that I haven't done is telling me that the interface is shut down. So in order to turn it on, I must say no shut. Stands for no shutdown. And it just told me I got a notification message, level 5, and it told me that the link just came up. If after reviewing your entire configuration, if it looks correct, then we can save it. So first, we would say show run. We're then going to take a look and make sure our configuration is correct. You can see how the service password encryption encrypted these passwords that we did not have the option of making them secret into an MD7 encryption. It is not the best encryption, but it is better than no encryption. You'll also notice that there was no executive timeout showing for line console 0. We made that 10. And the reason that it is not showing is that 10 is the default. The Cisco iOS will never show you a command if it is set to its default level. Once we have verified our configuration, we will say copy the running configuration to the startup configuration. We could now reboot this piece of equipment and make sure that it comes up using that configuration. So we will say reload. And it will go through and decompress the image. and then load the configuration file. Notice it has given me my banner message, and it is asking me to access or verify my access. We are entering through the console port. The command that or the password that we put in was Cisco con pass. Notice it doesn't show it to you as you are typing it in. It puts us into R1, into user mode. If I wish to go into enable mode, I would put in our enable password at this point. But it shows you that our passwords are now working. If I enter the wrong password, then it would tell me that I put in bad passwords. So if I type in enable, it will ask me for the password. And if I put in Cisco ENAPASS, it will ask me for the password again. Cisco ENA password. And it will ask me again. After 3 times, it will tell me that I put in bad secret passwords. Hopefully, this is just not my typing. If I put in the correct password, that was simply Cisco ENPASS, you'll notice that it did put me into privilege mode. I can now start accessing and adding different configurations. This concludes the basic router housekeeping for a router. Now that we have configured the router for basic configuration, we will turn our attention to a switch. I have powered up the switch. It's a C3650. It's actually a multi-layer switch so that we would be able to do routing capabilities as well as switching capabilities. For our discussion today, we will only be using the switching capabilities. The switch has no configuration, and again, just like the router, is asking us if we would like to enter the initial configuration dialog. To this, we will answer no. As you can see, it now says switch with the greater than sign rather than router. Just like in the router, we are in user mode. And to get into privileged mode, we will put in the same commands that we would on a router. First, enable. And then, now that we are in privilege mode, we want to go into global configuration. So we will say config terminal. Now, many of the things that we will be doing on the switch will be the same as the router. There are a few variations though. First, we will say no IP domain -lookup. Then I want to make sure that all passwords are encrypted. So just like on a router, we will say service password encryption. And just like a router, this will put anything that I don't use the secret keyword with into an MD7 encryption. I will name the switch. So name or host SW1. I can also set my domain. And I'll use the same domain that I used for the router, cisco-ccna.com. I can now set up my banner message. And I'll use the same banner message of the day that I used in the router. Administrator, access only. And remember, just like the router, your banner must start with a character and end with the same character, and the character cannot be part of the message. Now, depending upon the switch, we may not be able to set a minimum length for the password. It all depends upon the iOS, which commands will be available to you. But we will try it here. So we will say security, passwords, and it's telling us that we do not have that command on this particular device. If I want to see what commands I do have that begin with S, I have service, SNMP server, and spanning tree. Some devices may or may not have the ability to create the minimum length. If they have a security iOS, then we would have been able to enter the minimum length for the password. I now want to create my enable password. This is done exactly the same as it would be on a router. Enable, secret, Cisco, con for the console port, or actually this one should be Cisco EN for enable, pass. I can now also put in my username and password. So I created on the router a user Cisco admin. Just like on the router, I can create a privilege level. Privilege levels are the same, 0 through 15, with 15 being the highest. And I will create the password as Cisco admin pass. So we have set the banner. We have set our IP domain name. We have set our host. We can create now a encryption key. And the commands are the same: crypto, key, generate, RSA, general key, modulus 1024. I also want to prepare for using IPv6. IPv6 unicast routing. At any time, if you want to check what you have put in, you can always say do show run. So I have put in my encryption. I have put in my name. I've done the enable secret. I've turned on unicast routing. I've shut off the domain lookup. I put in my domain name. Notice the number of interfaces. And I put in my banner message. We can now continue with our configuration. And we want to make sure that we do have the username. So next is line console 0. Just like any other command, if I do not put in enough, it will tell me that the command is incomplete. And we will create our password. Cisco Con Pass. We want to tell it to use it. Login. We want logging to be synchronous. And we will set our executive timeout. Be 10 minutes. Now I've configured the console port. I'll now configure my auxiliary line. Password, Cisco, AUX, PASS. Login, logging synchronous, and executive timeout of 7 minutes. Notice, just like on the router, it just says config line. It does not tell you which line that you are in. We will now configure the VTY lines. This is where there is a change from the router. So it will be line VTY 0 space 15, because a router has 16 virtual, a switch has 16 virtual terminal sessions, while a router only has 5. And we will say login, use the local database, logging synchronous, executive timeout, and we'll make this 15 minutes. Finally, we want to tell it to use only encryption. So we will say transport input SSH. And that is all it will accept. Now, switch interfaces do not get an IP address, but we still need a way to manage this switch. And the management is a virtual LAN number 1. If I were to say do show VLAN, it would show me the different VLANs that I have. And you can see the only one that we have is VLAN number 1 default, along with these for fiber, token ring, another fiber, and TrueNet. We're going to concentrate on the VLAN 1. By default, this is the management VLAN. So I will say interface VLAN 1. This creates an SVI, a switched virtual interface. It does not exist physically. It is part of the fabric of the switch. Here we can also say description, and we will call it the management VLAN. On the SVI, we can put an IP address. .192.168.11.2. Remember, I used the 11.1 for the router. And the subnet mask. I can also say IPv6 address 2001:DB8:ACAD:2/64. I'd use the :1 on the router. And finally, a link local. FE80:2 link local address. The router or a host will be able to access the switch using those addresses. We also must turn on VLAN 1. As you can see, the basic router housekeeping configuration was almost exactly the same for the switch as it was for the router, except configuring the SVI. We did not have the minimum length command. The only other thing that we have to put in to the switch is a default gateway, because we are not currently using the switch in a routing mode. And it would be IP default gateway, and because we said IP, it is a IPv4 192.168.11.1. For IPv6, you'll notice that in Packet Tracer, there is no IPv6 default gateway. There is only one for IPv4. Again, before we finish, we want to show our running config. By default, all the gigabit interfaces, or all the interfaces, are up. I may not want to use all of my interfaces. So for this example, we can shut down interfaces that we are not using. I will go back into global configuration mode. And for this example, we will assume that we're going to use only addresses 7 and 8. I want to shut down the rest. On a switch, you can do these as a block of addresses. So I will say interface, range, gigabit, 1/1/1 to 6, because we are using 7 and 8. Now, on a normal switch, we would be able to put in a comma and then say gigabit 1/1/9-24, and then comma gigabit 1/1/1 to 4. I noticed that I put in ones where those should have been 0. So I will correct that. And this would be normal for a normal switch. But in Packet Tracer, sometimes we do not have the full command structure. In Packet Tracer, we could do one group at a time. So I am doing gigabit 1/0/1 through 6. Notice my prompt is config if range. And we will say shut down. The next group, if we are using 7 and 8, would be 9 through 24. And we will shut those down. And then the last group is 1/1/124. And we will shut those down. If I were to look at my interfaces now, you can see that all of the interfaces are shut down except for 7 and 8. My VLAN 1 management interface is up. My default gateway is there. My banner message is there. And all my passwords. Notice how it separates out the 0 through 4 and the 515 as far as my VTY lines are concerned. But putting them in as one group, the commands are repeated. Just like on a router, we would say copy running config to the startup config. I can then reload. Notice on the switch, it doesn't give you the pound sign as it is expanding the iOS. It gives you periods instead. It will ask me for the password. And we are going in through the console port, so it should be Cisco con PASS. And it has put us in. One thing I noticed, that it has not shown me my banner message. Scrolling back up to take a look at my configuration, I notice that my banner message is there, but it is not showing here. That is more than likely a packet tracer issue. I type in enable, password was Cisco, ENPASS. And now I am back into configuration mode. So you can see the only difference between configuring a router and a switch is on the switch you have to configure the management interface, whichever VLAN is being used for that purpose. You have to configure a default gateway because a router is its own default gateway. That's why we did not have to configure the router with it. And whatever ports that we are not using, because normally a switch is closest to the end user, we will shut those down. This concludes the initial configuration of a switch. We will now put what we have learned into a network. I have constructed the following circuit in Packet Tracer. This is taken out of the slides from the Cisco Academy. I am using the IP addresses that are provided for the slide in the Cisco Academy. The only addition that I have made is I have created a router to act as our internet to prove that it will work with the addresses of 200.0.0.1 and 2001 colon 200 colon 1 for the IPv6. We will now proceed to configure these devices. One of the easiest ways to configure devices either on Packet Tracer or using actual equipment, once you have gotten very familiar with the commands, is to use Notepad. This allows you to copy configurations and change addresses and other items that may change while keeping the ones that stay the same. Here, we will start configuring, and from these files, we will paste these into the actual devices in Packet Tracer. Working from the left side of the diagram to the right, the first device that needs to be configured is the switch. I usually just put a title. Then, again, once you are familiar with the housekeeping instructions, we can go directly down. So we will say, enable, configure terminal. I will change the size of the font to make it easier to read. At any point, if I want to put in a break to separate, I can put in an exclamation point. It has no effect on putting it into the device. So we will say no IP lookup service password encryption IP domain name Cisco CCNA .com. host name, SW1. Banner, MOTD. Administrator, access, only, and with the same character. Because this diagram uses IPv6 as well as IPv4, IPv6 unicast routing. Because I will want to use SSH, I will also create a crypto key. As you can see, I abbreviated the commands greatly. It stands for crypto key, generate, RSA, general key, modulus 1024. Now, as we saw on the switch, we could not put in the command for a minimum length password. So we'll create our password here. Enable secret, Cisco EN pass. We will create a username. And in this case, I will call it admin01. Secret. Admin01 PASS. If I wish, I could also put in that this is a particular privilege level. So I have my node IP domain lookup, my service password encryption, my domain name, my host name, my banner message. I've turned on unicast routing. I've generated a crypto key. I've created my enable secret password, and I've created a username. I will now say line console 0. Password, Cisco con pass. Login, logging synchronous, executive timeout, 10 minutes. You can also say now line auxiliary 0. Password, Cisco AUX pass. Login so that it uses that. Logging synchronous, executive timeout. We will make this 5 minutes. And now my VTYs. Remember there's 16, so it goes from 0 through 15. Here we will tell it to use our username. Login, local. Use the local database. Synchronous logging. Executive timeout, 15 minutes. And we need to tell it to use only SSH. I can now configure my VLAN. Interface VLAN 1. IP address. Before putting in that, I can always give it a description. And we'll call it connection to PC1. And maybe network. IP address. Now, because the router is using 1 and the PC is using 10, I will make this 2. So the IP address is 192.168.10.2. And the IPv4 address, plus the IPv6 address, excuse me, again, the PC is using the : 10. The router is using : 1. We will make this the : 2. And we will also give it a link local. Now I will use 1 for router 1, 2 for router 2. Switch 1, I will make this 1 : 1. Link local. I could make this much easier. Instead of 1, 2, I could just say that this is 3. And switch number 2 will be 4, which may be a better, easier way to understand this. I need to turn on VLAN 1. Now at this point, we're not quite sure what connections have been made to the switch. So I will not shut any of those down. I do need to put in a default gateway. Which will be the router's interface of 192.168.10.1. The beauty of using Notepad is that we can edit as we go. Router 1 is going to be very similar. So similar that if I copy what I just put into Notepad, I can now edit for router 1. The domain, the host name will be R1. One of the things that we were not able to put into switch 1 was the password. Security, passwords, minimum length of 10. The console line stays the same. Auxiliary stayed the same. The VTY lines on a router, we only have 5, so it's 0 through 4. Now, one thing that has changed is the interfaces. This interface is gigabit 0/0. I can leave the same description. The address is 1. The IPv6 address is 1. And the link local, because it's R1, we will use 1 as the link local. Because the router is the default gateway, we do not need the default gateway. I do need gigabit 0/1. So I am going to copy what I did for gigabit 0/0 and change it to gigabit 1. And this will connect to R2. The address is 209.165.200.225. And that, by the diagram, is going to be a /30. So it will have a 252 address. The IPv6, instead of being ACAD, it's feed. Colon 224. Colon 1/64. It will have the same link local because every link on the same device could have the same link local address. It is significant only to that link. And that router has a base configuration. We still need to add in some additional things, but it does have a base. Router 2 is very similar to router 1. We will just edit router 1 to configure router 2. So what is router 2? The rest of the housekeeping remains the same. First, gigabit 0, 1 we'll make that gigabit 00 will change to the PC2 network. The address being 10.1.1.1. The IPv6 address, instead of ACAD, it will be CAFE. And without the 10. And it is simply 1, colon, colon, 1. Actually, colon, colon. Yes, colon, colon, 1. And link local for router 2 can be 2. Gigabit 01 will be the connection to 1. The addresses, you notice, are in the same grouping, so it is very easy to change the addressing to 226 instead of 225, and 2 instead of 1. And again, the link local must also change. It's important when doing this that you go meticulously through to change the things that you need to change. Finally, we need to configure the second switch. You'll notice how I label these so that if I have an issue, I know where to go back to look. So this is for switch 2. The housekeeping stays the same. The connection to VLAN 1 actually now goes to the PC2 network. The IP address will change to the 10.1.1.2. The IPv6 address will no longer be ACAD, it will be CAFE, colon 1, and colon, colon 2. And this will be the link local of 4. The default gateway is that of the router. So for this one, it will be 10.1.1.1, that of router 2. Now, I have basic configurations in, but I have not given it any routing protocol yet. So we must put in the routing protocol. So I will go back to, first, R1. I am going to use the routing protocol of OSPF. So we will say router OSPF 1. And this is for IPv4. Router ID. And this will have an ID of 0.0.0.1, router 1. And I will put in the networks. Network 209.165.200.224, and a wildcard mask. It was a /30, so it is 0.0.0.3, area 0. The next network is 192.168.10.0, 0.0.0.255, area 0. On router 2, it will be very similar. There will be a couple of changes. The changes will be that the ID cannot be the same. So this must be a 2. The 209 network is the same for both, as that's the network that connects router 1 with router 2. The last network here needs to change to the 10.1.1.0 network. And then I have already put in default gateways going out to the internet, but we have to tell it to redistribute it. Default information originate. Now, for IPv6, the routing protocol is not set up exactly the same. So we will go back to router 1. First, I make sure that I am in the configuration for router 1. And then we say IPv6 router OSPF1. And again, just like in the IPv4, we have to give it an ID. Notice the ID, even though we are in IPv6, the router ID is an IPv4 address. We want to make sure the routing protocol is turned on. In IPv6, protocols could be shut off or turned on. That is all that's necessary there. IPv6 does not use the network commands. Instead, they are put onto the interfaces. So we would say IPv6 OSPF1 area 0. And we will do the same with our other gigabit interface. It is a much easier system putting it on the interface than it is creating network commands. Router 2, we will perform a similar setup. IPv6 router OSPF 1 router ID 0.0.0.2. Here, though, we also have to say default dash information originate. And again, on my interfaces, I would just say IPv6 OSPF 1 area 0. At this point, I have my configurations completed, or at least I hope they are completed. Do I have misspellings or mistakes in the commands? That is very possible. We will have to take a look as we put those into the devices. I have now switched back to the packet tracer diagram. First, I will go into switch number 1. I have gone into switch 1, and as you can see, I'm just getting generic messages. The switch has not been configured, as we can see from the switch greater than. If I highlight the information I typed into Notepad, copy it, and tell it to paste in, we can see that what I typed into Notepad has come into switch 1. I look up to see if there's any commands that gave me the caret, as in this case, the username. So we will correct that. Username, admin 01, privilege 15, secret, admin 01, PASS. The beauty in Notepad is that we can immediately edit any commands that were wrong. But we can't normally accept that everything went in correctly. That is why we scroll up, as in this case, to see if there were any carets. Now also, we want to see if we can discover what interfaces have been connected. But because at this time, the router has not been enabled, we could only see one. The way we would see that is to say, show IP interfaces brief, and I must remember to put do in front of that. And it will show us that all these interfaces are down except gigabit 102. I will assume that I am using gigabit 101 and 102. So we will shut down any of the interfaces that are not used. So we will say interface range gigabit 1 1/0/3 to 24 shut. Then range 1/1/124 shut. Now these commands, I can also highlight these and put those into my notepad file. Now, I have edited my notepad file, so it is now correct with what we have just put into the switch. Before moving on, we will check the switch by showing my running configuration and checking to make sure my host name is correct. I have all the different pieces in. My interfaces are shut down. My VLAN 1 is configured with IPv4 and IPv6. Again, I cannot have an IPv6 default gateway in Packet Tracer. Once I have verified that my configuration is as I wanted it, I would say copy the running config to the startup config. And except for testing, that interface is acceptable, or that switch is acceptable. I have switched over to PC1 because as I explained in other lectures, after I build a link, I wish to check it. So I am going to change the IP config of PC1. My IPv4 address will be 192.168.10.10 and a default gateway of 192.168.10.1. My IPv6 will be 2001 colon DB8 colon ACAD colon 10 colon 10. It will have a 64 prefix. My default gateway will be that of router 1, but it is the link local address. So the default gateway will be FE80 colon 1, which is the link local that we gave to R1. Once I have this information in, using the command prompt, I should be able to ping my default gateways. 192.168.10.1. Since the router is not up, I cannot make that connection yet. But once we wait for this to time out, I should, at this point, be able to ping the switch, which we gave the address of point 2, the virtual LAN, the VLAN, or my SVI. So I can get to the switch. So I have verified that that link is going between PC1 and switch 1. I should also be able to ping 2001 BB8 colon ACAD colon 10 colon 2. And I can get both IPv4 and IPv6 connections to switch 1. We will now move on to router 1. I have switched over to router 1. I will go into the command line. And again, this router has not received any kind of configuration. Highlighting and copying what we prepared in Notepad earlier, we can paste that into router R1. And we will look for any messages that our configuration was not correct. Again, I have an issue with my username. I have not corrected that. So we will correct that first. The highest I could go is 15. I mistyped using 16. Scanning. I also see that the router did not need the no shut, although that will not affect me. I'll continue scanning to see if there were any other issues. And it doesn't look as though I had any issues except those two, which are relatively minor. Now, with this configured, I should be able to ping both to my switch and to my PC. So I will say ping 192.168.10.10. That is the PC. And I have gotten success. I will try pinging the 2, which is my switch. And I have success. You'll notice sometimes the first ping is unsuccessful. I will try to ping 2001 colon DB8 colon ACAD colon 10 colon 2 first. That is the switch, which was successful. That is the host, and it was successful. Looking at this, I will assume, except for some corrections that may need to be done, that the configuration is good and accurate. So I will say copy running config to the startup config. I can now move on to R2. I have now moved on to R2. This, although it looks as though there is no configuration, if I show my run, I have configured R2 to get an IPv6 address through auto configuration and also an IPv4 address. I've also entered some IPv6 routes. And looking at this, there should not be 4, there should only be 1. So I will remove the extras. I will say no. Now, because these were duplicates, it may have removed all. So first, I want to do a show run. And you'll notice all of those have disappeared. The only one that I actually want is the last. So I will put that back in. I'll now select the configuration that we previously made for R2. And paste it in. Now again, I'm going to look for any carets. I have corrected the errors that we have found already. The only one that I may have gotten is when I had typed in enable, even though that we were already there. This did not give me any issue. You'll notice that my lines are now coming up. I will try pinging router R1. Notice I just got messages that my OSPF first version 3 This was for IPv6, and OSPF is for version IPv4. I now have a neighbor, and I should get networks. If I say show IP route, we can see that through OSPF, I have learned about the 192.168.10 network and how to get there. I also have a static route, which has become my gateway of last resort. When I say show IP route, it only shows me IPv4. If I want to see IPv6, I would have to say show IPv6 route. And you will notice that here I have my gateway of last resort. Through OSPF, I have learned about the 2001 DBA ACAD. The directly connected link locals. I know. This network I got through DHCP. Notice the ND for Neighbor Discovery Protocol. We will now verify that I can ping to the PC switch 1 and router 1 that I have already configured. First, I will ping the 209.165.200.225 interface, and I am successful. That is router 1. I will now ping 2001 DB8 feed 224 1. And I noticed my typing skills were a bit off. Should be a colon. And I'm successful. I will try pinging to switch 2, or switch 1, 192.168.10.2. And I am successful. Ping 2001 DB8 ACAD 10 : 2. Here I am having an error because in Packet Tracer, switch 1 does not have a default gateway for IPv6. For IPv4, we were able to get there. From R1, we were able to get there. I should be able to ping the host computer, PC1, because PC1 does have a default gateway of R1. And you can see that I got there. This just is a good demonstration of how important it is to have a default gateway for IPv4 or for IPv6. The only one that I have not pinged is the IPv4 of PC1. And we have verified that we can get there. So currently, I can go from R2 through R1 to PC1. I should also be able to ping my internet. And I was able to get to it. We will now configure switch 2. I have now come to switch 2. Going into command line, again, there is no configuration on this switch. I have highlighted and copied after making the corrections that we learned in the other devices to the configuration we created in Notepad earlier. Again, I will scan through to make sure that my commands went in there correctly. And with the corrections, we can see that there hasn't been an issue. I will save this configuration. So I will say copy, running config to the startup config. I realize that I did not save the configuration in R2. So I will have to go back eventually and save that in R2. Because I have configured now switch 2 and as well as R1, I should be able to ping the interfaces of R1, R2, and so on. So first I will say ping 10.1.1.1. You can see that we get a connection. I will also ping 2001 colon db8 colon CAFE colon 1 colon 1. And I have a connection to R2. You'll notice I was able to get to R2 because that is directly connected, even though I do not have a default gateway in switch 2 for IPv6. I should be able to ping 209.165.200.224, or actually 225, which is R1. I should also be able to ping 192.168.10.10, which is PC1. And I'm successful there. Because switch 2 did not have a default gateway, I should not be able to ping an interface other than that is directly connected at R2. To prove this, I will try ping 2001 colon db8 colon FEED colon 224 colon 1, which is R1. And with the lack of a default gateway in switch 2 for IPv6, it was not able to get there. I was able to get there in IPv4, but IPv6 fails because of that lack of a default gateway. We will finally configure PC2 to show a fully functional network. This is in, so I will say copy, running config, startup config. Now that it has been fully verified. It is a good practice that as you make changes, copy to save your work, especially in a simulation, in that if something happens, the simulation crashes, your work will still be saved. You save your configurations, save the file on a regular basis. I have switched now to PC2. As we can see from the diagram, this is a laptop. I will go in and do my configurations. The IPv4 address is 10.1.1.10 with a subnet mask of 255.255.255.0 and a default gateway of 10.1.1.1. The IPv6 address will be 2001 colon DB8 colon CAFE colon 1 colon 10. It is a /64 prefix. My default gateway will be that of router 2, and we will use the link local FE80 colon 2. We now wish to verify that we can get through our entire network. First, I will ping PC1 192.168.10.10. I've made it totally through my network, through switch 1, switch 2, router 1, router 2. I should also be able to ping my simulated ISP 200.0.0.1. And after a single timeout, I'm able to get there. Because this got all the way to PC1, we know that all the interfaces previous to that were good. I will try to ping the IPv6 internet, but Packet Tracer does have some issues with this. And as you can see, Packet Tracer does have some issues, although we know that we can get there via the IPv4. Now, putting in the SSH on these devices allows me to program these remotely. I'm currently at PC2, and I am going to SSH to switch 1. So in Packet Tracer, you notice that we have a Telnet SSH client. I will say that I want to go to 2001 colon DB8 colon ACAD colon 2. I will try using the IPv6 to see if it does work for me. We will use admin01 as our username. That is the username that I put in when we did the configurations. And I'll say to connect. The problem may not be getting there, but because of the lack of a default gateway in switch 1 for IPv6, that could limit our possibilities. So I will switch to IPv4. As you can see, we can make it with the IPv4 because of the default gateway in switch 1. Notice that my banner has come up and I am able to configure switch 1. I had forgotten to save the configuration in R2. So we will tell this to end. Actually exit, which will stop. We will now go to R2. This I should be able to get to via IPv6. Apparently, the IPv6 is having a problem there, so we will use SSH and IPv4. Now, as I said earlier, one of the things that I had forgotten to do was save the configuration of R2. So we will do that via SSH. Yeah. I had accidentally hit another key, which knocked me out temporarily, so I had to log back into it. If we were to take a look at the packets that went between the two as I did SSH, we would find that those packets are totally encrypted. We have now proven that with the proper configuration, we can get all the way through the network. We have configured our network and proven that we can get through it. Although we had some issues because of lack of particular commands in Packet Tracer, we were still able to prove that our configurations worked. Looking back at our notepad, first we took care of the housekeeping. No IP domain lookup, service password encryption, IP domain name, the host name, a banner message. We turned on IPv6 unicast routing. We generated a crypto key so that we could SSH. We created a secret enable password of Cisco EN Pass. We created a user and a password for use in SSH. On my console, on my auxiliary, we created a password. We told it to use it with the login command. We told it that I want synchronous logging so that it's not putting information at the end of a message. We turned on the executive timeouts. For the VTY, we told it to use the local database that we created earlier and only accept SSH connections. On the switch, we programmed the switch virtual interface, both with IPv4, IPv6. Where we had the slight error was that I was only able to put in an IP default gateway, not an IPv6 default gateway. And we shut down ranges of interfaces that we were not using to make our system even more secure. In the routers, we were able to set the security password minimum length characters of 10 characters. We only had 5 VTY lines, 0 through 4, while in the switches we had 16, 0 through 15. We labeled everything so that somebody coming up that did not know where a particular IP address went could take a look at the description and know. We configured both IPv4 and IPv6 routing protocols. You may notice IPv6 was actually a lot easier than generating a network statement in IPv4. And configuring the devices. Every step along the way, we checked to make sure the links worked, because there is no reason to put all configurations in and then have to go back and troubleshoot from the very first. Using Notepad is a very handy tool once you become familiar with the commands. Until you know how to enter the commands and can visualize what the result is going to be on a switch or a router, it is better to put them into the router to help you learn. Once you put in a command and you see that it didn't take it, you can troubleshoot it immediately there to correct it. This concludes the lecture for Module 10.